Today we are going to start with the assignment problem, and it deals in the industry with which job should be assigned to which worker so as to minimize the inefficiency or minimize the time. Okay, so suppose we take an example of a workplace where there are three persons working. This is person number one, this is person number two, and this is person number three. There are three persons which are working at some place, and they are able to perform three different jobs. This is job one, this is job two, and this is job three. Okay. Okay, these are the workers or the persons, and these are the jobs which have to be performed. Each worker is able to perform each job. Okay, there are three workers, and all these three workers are able to perform these three different jobs, but their efficiency of performing these jobs can vary. Okay, these jobs can vary. So we can have here, let us say that first worker can perform the first job. The first worker is also capable of performing the second job, and the first worker is also capable of performing the second job, third job, but with varying efficiency. Suppose the inefficiency here is 8, the inefficiency here is 7, and inefficiency here is 5. This inefficiency can be either it can be an inefficiency or it can be time. Okay, so these variables, what we call as the CIJ, the cost matrix. Okay, these can be the times, either we need to minimize the time, or it can be inefficiency of the worker, that is we need to minimize the inefficiency of the worker. Minimizing the inefficiency means we are increasing the efficiency. Okay, so this is the first worker, he is able to perform these jobs. To perform the job number one, he is taking suppose 8 units of time, or it means that he has the best efficiency for him is to perform the job number 3 because he is able to do it in small time, or the inefficiency associated with the worker in performing the job 3 is less. This is the thing that we have to minimize. Okay, similarly, let us take the example here. Worker number second is able to perform job number 1, 2, and 3, but with varying times or varying efficiencies. Okay, suppose the time he's taking here is suppose 10 units, or he's taking 11, or suppose he's taking 4. Okay, similarly we can take the example of person number 3 who is able to perform the jobs and suppose their inefficiencies be suppose 9, suppose 6, and suppose 12. Okay, these are the inefficiencies, or what we call as them the times. Okay, time is also proportional to inefficiency. जिस वर्कर को ज्यादा टाइम लगता है, that is he is inefficient in performing that job. Time is also proportional to inefficiency. Okay, so in our current case is that we have to minimize this inefficiency. Okay, we have to minimize this inefficiency, and how we can allot a suitable job to the suitable worker. Okay, although the worker is able to perform all these jobs, but which job will be suitable for the particular worker such that the time is reduced or inefficiency is reduced, inefficiency associated with that job is reduced. Okay, so this is the main motive of this problem, and let us define this problem first. How we can define the problem? we can see here the problem will be defined again in terms of the minimization. Okay, the problem here, just like as in the transportation problem, it is again the minimization problem. So let's first of all define this problem. It is again a case of a linear programming problem. It's again the case of a linear programming problem. So first of all, we have to see what are the decision variables here. Okay, suppose in this case I have taken 3 jobs and 3 workers. Obviously, we are going first of all to start with balanced assignment problem. We'll start with an balanced assignment problem. And balanced assignment problem is that problem in which the number of jobs is equal to the number of workers. Okay, if we are having n workers, therefore if we are having n jobs, then we can say that the assignment problem is balanced. Okay, suppose I am having n decision variables here. Okay, suppose I'm having n jobs. Okay, suppose I'm having n jobs, then the decision variables will be equal to n square. Okay, the decision variables will be equal to n square, because we will get a 3 cross 3 matrix, cost matrix. That will be a 3 cross 3 matrix having 9 elements, and therefore the decision variables will be equal to n square. Okay, this is one thing. The most important thing here is the decision variables, that is xij in this case, are these are binary variables. These are binary variables. Okay, these are binary variables. और हमें पता है कि binary variables can take only 2 values, that is 1 or 0. This is the possible allocation of the binary binary variables. It can take the values of 1 and 0. What does it mean? That suppose I'm talking about xij, suppose I'm talking about the worker 1. Okay, I'm talking about the worker 1. What does it mean that worker 1, if a job is assigned to the worker 1, suppose x1 first job is assigned to the worker 1, it means that x11 will be equal to 1. Okay, x11 will be equal to 1. It means that first job is assigned to worker 1. Okay, first job is assigned to worker 1. एंड सिंस मैंने आपसे कहा कि एक वर्कर को एक ही जॉब हम असाइन कर सकते हैं, okay, we can assign only one job to one worker. Therefore, if we are talking about x12, it should be equal to 0, because worker first को already assign किया हुआ है job number 1. Okay, if a particular job is assigned to a particular worker, then we say that xij will be equal to 1. लेकिन अगर अब इसको असाइन किया हुआ फर्स्ट वर्कर को फर्स्ट जॉब असाइन हुआ है, therefore x11 is 1, x12 will be 0, and x13 will be equal to 0 as well, because first job has already been assigned, first worker has already been assigned job number 1. Therefore it means that it can take either the value of 1 or it can take the value of 0. Okay, so these variables, decision variables here, are the binary variables, since they can take the value of 1 or 0. Therefore, I can write that This xij is actually what? Binary variable. And xij will be equal to 1 if ith worker is assigned job j. Okay, or it can be equal to 0 if ith worker is not assigned job j. Okay, so simply in this case the decision variables can take value of 1 or 0, unlike in the transportation problem जहाँ पे इनका transportation problem में decision variables were number of units, कितने यूनिट्स हम ट्रांसपोर्ट कर सकते हैं फ्रॉम a particular source to a particular destination. But here these decision variables can take only 1 or 0. If it is taking 1, then that decision variable means that ith worker is assigned jth job. Or we can say that if it is 0, then we can say that the job has not been assigned to that worker. Okay, the job has not been assigned to that worker. So this is how we define the decision variables in the assignment problem. Let's take a look at the minimization problem now. Cij is inefficiency associated with worker I performing job J, or sometimes it is also explained in terms of the time taken by worker I in performing job J. ठीक है, so this is how we define the Cij in this case. In the transportation problem, the Cij was the cost per unit. यहाँ पे हम क्या कह सकते हैं? It is the inefficiency associated with the worker I in performing the job J. और inefficiency is also proportional to the time. ठीक है, जिस वर्कर को जितना टाइम ज्यादा लगता है, we say that he is that much inefficient, or we can say that it is the time taken by the worker I in performing the job J. In both the scenarios, whether it is the inefficiency or whether it is the time, we have to minimize this thing. Okay, we have to minimize these things. Therefore, our actual transportation problem will become, sorry, this assignment problem will become, it will become minimize z equal to summation of I, summation of j, Cij, Xij. Okay, it is similar to that of the transportation problem, but here the Cij and Xij carry different meanings. Okay, these carry the different meanings, and this is the problem here. And what is this? This is the objective function, and we know that every objective function in the linear programming problem is subjected to certain constraints. And let us discuss what are these constraints. अगर आपको याद होगा transportation problem में the constraints were the demand constraint and the supply constraint. Here the constraints will be, the first constraint is equal to summation of I Xij should be equal to 1 for every j. And I will write the second constant as well, summation of j Xij should also be equal to 1 for every I. Okay, so what does it mean? What does it mean? So अगर मैं first constant की बात करता हूँ, let me write the first constraint. The first constraint can be expanded. Okay, I will expand the first constraint. Summation of Xij should be equal to 1. Okay, for every j. It means that For my problem it was if I is equal to 1, ठीक है, I मैं लेता हूँ 1, okay, for I is equal to 1, therefore x11 plus x12 plus x13 should be equal to 1. Okay, it should be equal to 1. What does x11 mean? X11 means it can take the value of 1 or 0. It can take the value of 1. X12 can take the value of 1 or 0. Similarly, x13 can take the value of 1 or 0. ठीक है, तो ये एक्सपेंड करके क्या आना चाहिए, इनका समेशन आना चाहिए 1. सो इसका पहला मतलब क्या है, इसका कांस्टेंट का मतलब क्या है? आई विल राइट दैट दिस कांस्टेंट रिप्रेजेंट्स दैट a person gets only one job. इसका मतलब यही है, a person gets only one job. ठीक है, तो पहले पर्सन की या पहले वर्कर की हम बात करते हैं. ठीक है, let's talk about the worker number 1. If I am talking about the worker number 1, then I is equal to 1 because I is the first worker. Okay, I is the first worker. Here in these all these terms, what represents? I represents the worker and J represents the job. This I symbol is usually used for the worker and J symbol is usually used for the job. So अगर हम पहली constant की बात करते हैं that a person will get only one job. Let's talk about the first person. The first person is I is equal to 1. Therefore, if a person is getting only one job, okay, इसका summation किसके बराबर होना चाहिए? 1 होना चाहिए. ठीक है, let me suppose that a person has been assigned. Let me suppose that person 1 has been assigned job 2. ठीक है, if I am talking that a person 1 has been assigned job 2, so can anyone tell me what should be the value of this decision variable x11? क्या होना चाहिए? What should be x11? Can anyone tell me what should be x11? If the person 1 has been assigned job 2, what should be x11 in this case?
0.
Yes, oh, very good. It is 0. Because I told you that x11 will have only two values. Either it will be 1, either it will be 0. x11 will be equal to 1 if the worker 1 had been assigned job number 1. But the worker 1 has been assigned job number 2. Therefore, this x12 will be equal to 1 and x13 should again be equal to 0 because first worker has not been assigned job number 3. Therefore, it is equal to 0. So in short, what does this constraint represent? It represents that if there is a person, he will get only one job. So ये जो first constraint है, ये मैंने किसके लिए लिखा है? It has been written for the first person. Again, this is not a single constraint. कितने constraint है ये इस example में? ये जो constraint मैंने पहला constraint लिखा है, कोई मुझे बता सकता है ये कितने constraints को represent करेगा? It is not a single constraint. It is not a single constraint. Can anyone say how many constraints this constraint will represent in actual?
3.
Very good. It is for the 3 because यहाँ पे n3 है, यहाँ पे 3 persons है. So the first person के लिए मैंने आपको दिखाया. For second person again, for second person we say that I is equal to 2. Therefore, the second constant will become x21 represents second job assigned to 1. Okay, sorry, second person has been assigned one job, second person has been assigned second job, second person has been assigned a third job, but this should be equal to 1. अगर मैंने सपोज यहाँ पे second वर्कर को जॉब नंबर 3 असाइन किया है, ओके, फॉर एग्जांपल वर्कर 2 को जॉब 3 असाइन किया गया है, then we can say that x23 will be equal to 1 and x22 will be equal to 0. This will again be equal to 0 because worker second has neither been assigned job number 1 nor assigned job number 2, but worker second has been assigned job number 3. Therefore, this should be equal to 1. Similarly, if I'm talking about the third person, again, this summation should be equal to 1. Okay, these x31, x32, they won't take any decimal values. They will either take 1 or they will take 2. Suppose मैंने क्या कहा यहाँ पे, अगर अब यहाँ पे job number 1 रह गया है, suppose that has been assigned to the worker number 3, then this will be equal to 1. Worker number 3 is not being assigned job 2, not being assigned job 3, because he can perform only one job. Therefore he is capable of performing all these 3 jobs, लेकिन इसको assign किया गया है job number 1. Therefore x31 will be equal to 1, other will be 0. Okay, so these all represent the first constraint. Okay, first constraint can be further divided into the 3 constraints, or in general we can say that it can be divided into n constraints. Okay, it can be divided into n constraints depending upon the these jobs and the workers. Okay, similarly, second constraint here, it is actually representing what? This constraint here, the second constraint is actually representing a job. A job is performed only by one person. A job is only performed by one person. तो ऊपर वाला constraint क्या था? A person is performing only one job or getting only one job. And second is that a job is being performed by only one person. Okay. So अगर हम job number 1 की बात करते हैं, if we talk about job first means that j is equal to 1. So if I expand that constraint again, it will be equal to worker 1 performing first job, or worker second performing first job, or worker third performing the first job. Okay, because I have kept j is equal to 1, which means that job 1 की हम बात करते हैं, either it will be performed by the first worker, or it will be performed by the second worker, or it will be performed by the third worker. This summation should be equal to 1. Obviously जो worker इस job को perform करेगा, that will be having the value of 1. Suppose second worker is performing job number 1, I can say that this value will be equal to 1, and the job number 1 won't now be performed by worker number 1 or worker number 3. Therefore these values can be 0. Okay, so similarly for the job number second, I can write that x12 plus x22 plus x32, that should be equal to 1. And similarly for job number 3, x13 plus x23 plus x33, that should also be equal to 1. Okay, so this constraint represents that a particular job will be performed by only a particular person. Okay, so this is the nutshell of the what we call as the assignment problem. Okay, and we have to minimize this problem. So we have defined the assignment problem as minimize z equal to summation of I summation of j cij into xij. Okay, cij into xij. Okay, cij into xij, where it is subjected to these constraints. Xij is equal to 1 summation, and summation of xij is again equal to 1 for every j or for every I. And also these decision variables, okay, can be either 1 or they can be 0. Okay, that's why I had already told you that these are the binary variables. Okay, they can't take any other value. Okay, they can take any other value. So जो order होगा assignment problem का, suppose in our case I have taken an assignment problem of order number 3, तो उतने ही decision variables का value 1 होगा. Okay, only those decision variables have value 1. So क्या मतलब है इस बात का? Okay, if n is equal to 3, that is order of the assignment problem is equal to 3. N is equal to 3 means we have 3 jobs and 3 workers. Since n is equal to 3, the number of decision variables will be equal to n square. ठीक है, decision variables will be equal to n square. So इस case में जो number of decision variables will be, they will be equal to 9, since I have taken the example of the मैट्रिक्स ऑफ ऑर्डर 3। ओके, लेकिन इनमें से क्या होगा, इनमें से ओनली n decision variables will have the value of 1। ठीक है, ये भी मैंने एक्सप्लेन किया है कि 9 डिसीजन वेरिएबल्स में सिर्फ 3 ही को 1 वैल्यू मिलेगा, बाकी को क्या मिलेगा, द वैल्यू ऑफ 0, because we have only 3 jobs, therefore we will have only 3 decision variables whose value will be assigned as 1। ठीक है, तो उसी का मतलब है कि हमने assignments कितनी possible है इसमें, assignments possible are only 3। So these n decision variables also represent that, this statement also represents that number of assignments possible is number of assignments that are possible is equal to n। Okay, although we have n square decision variables, but only 3 of them, only n will have what, the value of 1, that is 3 assignments will have to be made। Okay, it's obvious that 3 assignments will have to be made because we have 3 jobs and 3 workers, therefore each worker will get only 1 job, hence the number of assignments is equal to n। Okay, this is the definition of the assignment problem। Okay, and currently we will deal with the balanced assignment problem since we are having the number of jobs equal to the number of workers। Okay, this is the assignment problem। So how to solve this assignment problem? Again, it is a linear programming problem, but we won't use any kind of graphical method or the simplex table. Just like we had devised some algorithm for the transportation problem, we had seen various methods for the transportation problem. Similarly, for solving the assignment problem, we have an algorithm that is known as Hungarian algorithm। And there is an algorithm which is known as Hungarian algorithm। Okay, so what does it say? That its first step is that, first step, if I write the first step of the Hungarian algorithm, locate the minimum entry in each row and subtract this minimum entry from each element of that row। The second step is that locate the minimum entry in each column and subtract this minimum entry from each element of that column। Okay, suppose that these are the first 2 steps। Okay, and I can show this by one example here। Suppose this is the matrix which will be given here. The question is given in the form of the matrix, and since it is an n cross n matrix, here n is equal to 4, you can see that n is equal to 4, therefore we will have 4 persons। Suppose the persons are person A, B, C and D, and we will have 4 jobs. Suppose the jobs are J1, J2, J3 and J4. Okay, these are the jobs here. Okay, these are the jobs here. And what will be in these elements? The elements will be Cij. Okay, this is C11. Suppose it is equal to 10. And I told you that this C11 represents the inefficiency or the time taken by person 1 in completing the job number 1. Similarly, person A in completing the job number 1. Similarly, we have these entries which are given by this 16, 10, 18, 12, 8, 4, 8, 14, and after that we will have 20, 8, 16 and 6. Okay, so these are all either the inefficiencies of the person associated in doing the job, a particular job. Okay, suppose I am defining this here. अगर मैं इसको define करता हूँ यहाँ पे, it is the inefficiency of person B to do the job number 3, or we can say that it is the time taken by the person B in doing the job number 3. Okay, so these are the elements given, and we have to see what is the proper assignment. 4 jobs are to be distributed among the 4 workers, and what is the efficient way of doing this assignment, that we have to see. And this can be seen by the Hungarian algorithm. Okay, this can be seen by the Hungarian algorithm. तो सबसे पहले हम लॉजिक डिस्कस करते हैं. Suppose I am talking about the first row. The ideal condition here is the ideal condition here is the ideal condition for the company would have been there is no efficiency, no inefficiency. There is no inefficiency associated in a person doing a job. Okay, ideal condition would have been that there is no inefficiency associated in a person, okay, doing a particular job. What does that mean? Then we can say that he is talking about that Cij is equal to 0. Okay, he is talking that Cij is equal to 0. Okay, this is the ideal condition कि जो person job कर रहा है उसमें कोई भी inefficiency नहीं है, or we can say that it is the criteria of the 100% efficiency. Okay, inefficiency 0 means it is the criteria for the 100% efficiency. So this is the ideal condition which we are looking for. तो अगर हम पहले रो की बात करते हैं हम, if we are talking about the first row, there is a person A who is able to do job number 1, 2, 3 and 4. We would have wanted such an entry in this first row that would have been equal to 0, whose Cij would have been equal to 0, because it means that its efficiency is 100%, or the inefficiency is 0. Inefficiency for the person A for performing any job should have been 0. Okay, it should have been 0. So इसमें क्या है? Here we have 10, 14, 22 and 12, but we don't have any 0. Okay, we don't have any 0, so that we could have assigned that directly. अगर यहाँ पे किसी भी एंट्री में 0 होता, ठीक है, सपोज यहाँ पे 14 के बदले 0 लिखा है, उसका मतलब क्या है? That there is no inefficiency of the worker A in performing the job number 2. There is no inefficiency associated, or there is 100% efficiency associated. So our mind would have suggested that give the job number second to the person A, because Cij is 0 for it. Okay, but how will we get a 0 here? Okay, this is the question. How will we get a 0 here? We don't have 0 values here. We have some definite positive values. Okay, हमारे पास जो values है, they are some positive values, 10, 14, 22 and 12. Okay, so first thing comes in our mind, पहला पहली जो बात है हमारे दिमाग में आती है that there should have been a zero in this row, and in fact there should have been at least one zero in every row. ठीक है, सपोज यहाँ पे अगर यहाँ पे जीरो इस रो में होता तो हम इस वर्कर ए को जॉब नंबर 2 असाइन करते। सपोज यहाँ पे अगर जीरो यहाँ पे होता 18 के बदले यहाँ पे जीरो होता, हम किसको असाइन करते? बी पर्सन को जॉब नंबर 3 असाइन करते। सिमिलरली इफ देयर वुड हैव बीन अ जीरो हियर, we would have assigned job number 1 to the worker D, because inefficiency of the worker D in performing this job number 1 is 0. That is, it is 100% efficient in performing job number this D. Okay, DJ1. And suppose यहाँ पे अगर 0 होता, then we would have said that C person is best suited for performing the job number 4. But we don't have zeros here. Okay, we don't have zeros here. But how to get these zeros here? This is the main condition. This is the main problem. ठीक है, अब हम zero कहाँ से लाए यहाँ पे? So this is the first thing that comes in our mind, is that we need an ideal condition that Cij should be equal to 0. Now how to get Cij is equal to 0? The Cij is equal to 0 will be given by the condition that if we subtract same if we subtract a particular number from each element of a particular row, if we subtract a particular number from each element of a particular row or column, the assignment won't change. This is the condition which gives us the, यही कंडीशन हमें डिसाइड करेगी अब हम जीरो कहां से लाए। तो वो किस पे बेस्ड है? इट इज बेस्ड ऑन द थिंग दैट इफ वी सब्ट्रैक्ट अ पर्टिकुलर नंबर फ्रॉम, so to solve the assignment problem, first of all what comes to my mind is that if I'm talking about the row number A, that means person A को मैं कौन सा जॉब देना चाहता हूँ, I would like it to give him the job whose cost is 0. Okay, Cij is 0, but we don't have Cij is equal to 0, but we would like to create a Cij is equal to 0. How to create that Cij is equal to 0? For that we can use a different logic, that if we subtract a particular number from each element of a particular row or column, the assignment won't change. तो चलो अभी what does this mean? Forget the table below the first row. Okay, forget this row number B C D. Okay, forget all the elements which are present in the B C D rows. Okay, just concentrate on the row number A. Okay, पहला रो है उस पे concentrate करो। अगर मुझे असाइनमेंट करना होता to the person number 1, ठीक है, suppose there is only one person A and there are 4 jobs to be performed, J1 J2 J3 and J4. So आप person A को कौन सा job देते? Can anyone tell? Which job would have you preferred for the person number 1, person A?
Job first.
Okay, obviously job first, because in performing the job 1 he takes the least amount of time, or the inefficiency associated with the person A in performing the job number 1 is least. Okay, you would have given the job number 1 directly to the person A. Okay, अगर सपोज यहाँ पे कुछ नहीं होता, BCD नहीं होते, सिर्फ एक पर्सन होता और उसको 4 जॉब्स में से एक जॉब करना होता, you would have directly assigned him this job number 1. Let me give you one more condition here, is if I am subtracting 2 from each element, if I am subtracting 2 from each element, the new elements will be 8, 12, 20 and 10. अब मुझे बताओ आप कौन सा जॉब इसको देते? Which job would have you given to the person A? I have just subtracted 2 from each element, okay, of that row.
फिर से J1 कोई.
Okay, obviously it won't affect subtraction or addition of any element to each of these entries won't change the assignment. यही मैंने यहाँ पे लिखा. If we subtract a particular element from each particular number, okay, if we subtract a particular number from each element of a particular row or column, the assignment won't change. This is the second step which I have written here. और इसी स्टेप की मदद से हमें क्या मिलेगा? We will get a zero in, we will get what? We will get a zero in each row. Okay, we will get a zero in each row and each column. Okay, so see here what I have written in the Hungarian algorithm. The first step, locate the minimum entry in each row and subtract this minimum entry from each element of that row. Okay, we have to locate the minimum entry in each row and we have to subtract that minimum entry from each element of that row. And what is the value? इसकी significance क्या है? इसकी significance ये है कि हमें एक zero, कम से कम एक zero आ जाएगा उस row में. So अगर हम same principle पहला step apply करते हैं इस table पे, okay, if we are applying the first step on this table, what will happen here is we have to subtract from each element of each row the smallest entry of that row. I need to write this matrix again. It is equal to 10, 14, 22, 12, 16, 10, 8, 14, 8. Okay, so this was the person A, this was the person B, C and D. We had 4 rows and we will have 4 columns, J1, J2, J3 and J4. Okay, the first step is that we have to perform a row operation. And in performing the row operation, what we have to do, we have to see what is the smallest element in each row. So if we go to the row number 1, the smallest element is 10. Okay, the smallest element is 10. Therefore, this element will be subtracted. This number will be subtracted from each element. Okay, so 10 minus 10 will be equal to 0. 14 minus 10 will be equal to 4. This will be equal to 12. And this will be equal to 2. Okay, so we have made a 0 in the first row. And this subtraction won't affect the what we call as the क्या कहते हैं हम इसको, ये असाइनमेंट को अफेक्ट नहीं करेगा. बिकॉज अभी मैंने आपको पुरानी स्लाइड में एग्जांपल दी थी कि अगर मैं कोई भी नंबर, ठीक है, इन सारे एलिमेंट से सब्ट्रैक्ट करता हूं, द असाइनमेंट वोंट इफेक्ट. सो व्हाट इज द नंबर दैट वी हैव टू सब्ट्रैक्ट? दैट ऑब्वियसली विल बी द मिनिमम एंट्री. अगर मैं मैक्सिमम एंट्री लेता या कोई और एंट्री लेता तो कोई असाइनमेंट जीरो बन जाता, सॉरी नेगेटिव बन जाता है ना. सपोज if I would have subtracted the maximum entry, if I have subtracted the maximum entry, ये -12 बन जाता, ये -8 कुछ बन जाता, ये 0 बन जाता, ये कुछ -10 बन जाता. But those Cij can't be the negative, okay, because time can't be negative or the inefficiency can't be negative. Okay, inefficiency or efficiency can't be negative. Therefore, we have to select the least entry of that row. Similarly, if we are looking at the second row, the least entry is 10. Okay, second row, least entry is 10. 16 minus 10 is 6. 10 minus 10 is 0. 18 minus 10 will be equal to 8, and 12 minus 10, that will be equal to 2. Okay, this is the row operation. And similarly for the row number 3, we will have 0, 6, 0 and 8. And for the last row, the least entry is 6. Therefore, 20 minus 6. Okay, sorry, 0 यहाँ पे. So this is the row operation. And what has been,
और की जगह 6 ही आएगा.
क्या आएगा?
6 0606.
6, okay. So this is the row operation. And what we get after the row operation is that row operation ensures at least रो ऑपरेशन एंश्योर्स एटलीस्ट 1 0 इन ईच रो। ठीक है, आप देखो हर किसी रो में एक 0 आ गया। ठीक है, उसके बाद सेकंड स्टेप क्या है? सेकंड स्टेप इज दैट परफॉर्म द कॉलम ऑपरेशन। Okay, this is what? This is the row operation, and second step is perform the column operation. Row operation in fact। और आप स्टेटमेंट पढ़िए, आप सेकंड स्टेटमेंट पढ़िए, क्या लिखा है इसमें? Locate the minimum entry in each column and subtract the minimum entry from each element of that column। ठीक है, अब यही ऑपरेशन हमें क्या करना है? कॉलम पे आओ। ठीक है, and from here I think you can see that there is already 1 0 in each column। ठीक है, यहाँ पे कॉलम ऑपरेशन करने की जरूरत नहीं है, बिकॉज हर किसी कॉलम में क्या है? 0 है। That is the least entry, and if we subtract 0 from every entry of that column, we will again get the same matrix। Okay, so here after that, after the row operation, no need for column operation, no need for column operation, as there is 0 in each column, at least 1 0 in each column। Okay, at least we have 1 0 in each column। Okay, so suppose किसी कॉलम में 0 नहीं आता, तो आप क्या करते? उस कॉलम पे आप क्या करते? कॉलम ऑपरेशन करते, so that you will get an another matrix which is the reduced matrix second। Okay, this is the reduced matrix 1। After this you would have got a reduced matrix second, in which we have performed the column operation, but this is such that we don't need to perform any column operation because we already have 0 in each row। Okay, but in majority of the cases यहाँ पे ये हो गया 0 खुद से, but in majority of the cases you need to perform the column operation as well, which was shown in the second step of the Hungarian algorithm। Okay, so this is the second step. After this, so the first and the second step, that is the row and the column operation, are performed to ensure that there is at least 1 0 in each row and each column। Okay, so we can see that row column operations, okay, row and column operations are performed to ensure at least 1 0 in each row and column। Okay, now what is the third step after we do the column and the row operation? The third step is that now examine the first row। Okay, now examine the first row। Okay, once we have got the reduced matrix after performing the row operation and the column operation, now examine the first row of the matrix got after second step, that we got after second step। What we have to do here is, if there is only 1 0, if there is only 1 0 in that row, if there is only 1 0 in that row, mark it with a square and cross all zeros in that column. Okay, क्या कह रहा है ये? Examine the first row of the matrix that we obtained after the second step. If there is only one zero in that row, mark it with a square and cross all the zeros in that column. So let us apply this step to here. Okay, this is the matrix which we have obtained after the row and column operation. So look at the first row. Okay, look at the first row. There is only a single zero. Okay, आप statement फिर से पढ़ो. If there is only a single zero, if there is only one zero or a single zero in the first row, then what we have to do is we have to mark that with a square. इसका मतलब क्या हो गया कि इसका मतलब हो गया कि ये assign हुआ. ठीक है, इसका मतलब ये है कि job A has been assigned to the job 1 has been assigned to the worker number A. Okay, so if you read the statement again, examine the first row of the matrix got after the second step. If there is only one zero in that row, mark it with square and cross all the zeros in that column. Okay, further it states that repeat it for all the rows. Okay, same step we have to repeat for all the rows. Repeat it for all the rows if there are more than one zero in a particular row. Skip that row and move to another row. Okay, skip that row and move to another row. So ये क्या कहता है कि the step is that once we have assigned it what, okay, examine the first row. If there is only one zero in that row, mark it with a square. और उस कॉलम में अगर, ठीक है, उस कॉलम में अगर कोई और जीरो हुआ, that we have to cross. So see the first column, there is a zero, so this will be crossed. ठीक है, ये जीरो क्या होगा, क्रॉस होगा. क्योंकि आप देखो पर्सन ए को क्या अलॉट हुआ है, जॉब नंबर 1 हैज बीन अलॉटेड टू द पर्सन 1. जॉब नंबर 1 हैज बीन अलॉटेड टू द पर्सन ए. तो एक जॉब को सिर्फ एक ही पर्सन कर सकता है. और हमने क्या किया, हमने जॉब नंबर 1 पर्सन ए को दिया. सो अगर आगे जाके हमने ये क्रॉस नहीं किया होता, देयर वुड हैव बीन पॉसिबिलिटी दैट कि यहाँ पे वर्कर सी था, आप उसको असाइन करते. लेकिन job 1 is already assigned to the worker A, therefore उस job वाले column में कोई और अगर zero हुआ, that has to be cross marked. ठीक है, उसके बाद क्या है, we have to repeat this for the all these rows. Once we have assigned the first row, now coming on to the second row, see if there is only one zero. ठीक है, अभी आप देखो, I will show you the step again. If there is only one zero, okay, if there is only one zero in that row, mark it with a square and cross all the zeros in that column. Repeat it for all the rows. Lekin if there are more than one, if there are more than one zeros in a particular row, skip that for the time being and move to another row. Let us see what is the condition in the row number second. In the row number second, there is only one zero. Okay, there is only one zero. Therefore, this will be assigned and cross all these. Okay, we have to make a cross on what, we have to make a cross on all the other zeros present in that column. Okay, we have to make a cross present in all those present in the column. Okay, now coming on to the, यहाँ पे कोई zero नहीं है इस और column में, so कोई cross mark करने की जरूरत नहीं है. So moving on to the row number 3. Okay, see here in the row number 3 there is one zero. Okay, but it is not a single zero initially a single zero नहीं था. यहाँ पे तो आपको दिख रहा है that there is a single zero, but this single zero has been, ये कहाँ से आया, जब हमने एक क्रॉस मार्क मारा है ऑलरेडी यहाँ पे इस रो में ओरिजिनली कितने थे, 2 जीरो थे, एक पे क्रॉस मार्क है, एक यहाँ पे रहा है, therefore for the time being this won't be assigned, ठीक है। If originally there would have been a single zero, we would have directly assigned it, but let us wait and go on to next row, ठीक है, let's wait and go on to next row. So in the next row, what is here, there is a single zero and this is originally present, single zero, this single zero was originally present, ये single zero किसी cross वगैरह की वजह से नहीं आया, ठीक है। So we will do what, we will mark this, okay, this has been assigned. So once all has been assigned, ठीक है, once all rows have been assigned, the next step is that, the fourth step is that perform step 3 for all columns as well. जैसे हमने रोज के लिए ये किया स्टेप नंबर 3, वैसे ही स्टेप नंबर 3 क्या करना है कॉलम्स के लिए भी ऐसे ही है, ठीक है। So moving on to the first column is already assigned. Moving on to the second column is already assigned. Moving on to the third column, there is only 1 0 in the third column and that will be assigned. The fourth column is already assigned, okay. So the optimal assignment is here, AJ1 B is given to J2, C is given to J3 and D is given to J4. And what is the inefficiency associated? वो हमें original matrix से देखना है 10, 10, 8 and 6, okay, 10, 10, 8 and 6. तो अगर ये कहता है कि ऑप्टिमल असाइनमेंट में कितना टाइम लगता, सपोज ये टाइम दिए होते यहाँ पे, so this would have added to 34, okay, this is suppose 34 hours लगे होते, this is the optimal assignment, ठीक है। अगर कोई भी असाइनमेंट आप देते हो इसके अलावा, ठीक है, कोई भी असाइनमेंट आप इसके अलावा देते हो, that would have been what, that would have been not optimal, ठीक है। Can anyone say what is the total assignments possible? How many, what are the number of ways, total number of ways by which assignment can be made? Can anyone say? If the order of the matrix is n, total number of ways in which assignment can be made. कोई मुझे बता सकता है? Can anyone say the total number of ways in which this assignment could have been made?
N.
n अगर 4 ही पॉसिबिलिटी है, 4 पॉसिबिलिटी तो पहले वर्कर को ही खत्म हो जाती है। ए को हम J1 16, it is actually n factorial. It will be n factorial. Okay. It will be n factorial as far as I remember.